everyone, hope you're all doing well. This is Zainab Zaytoun. In this video, I'll explain the third and the final part of antiderivatives for grade 11. And as I said in the previous videos, this is a revision for grade 12. However, I highly advise grade 12 students to watch it too, since this part is important. The objective of this video is to solve integrals by change of variable, and it's often known as U-substitution. Let's start our lesson by solving this integral. So the integral of 2x into x squared minus 1 all squared. How can we solve this type of integrals? You know that you can't split the integral as the integral of 2x times the integral of x squared minus 1 all squared because there's a multiplication. You can just split the integrals when you have plus or minus using linearity, so addition or subtraction of two functions. So what do you think we can do about this integral? Maybe changing its form? Let's try. In order to change the form of this integral, the only way is to start by expanding. So let's use the identity to expand this x squared minus 1 all squared. So using the identity, it'll be the first term squared minus 2 into the first term times the second term plus the second term squared. Then this will be x power 4, this will be minus 2x squared, and this will be 1. Now expand again, you will get 2x power 5 minus 4x power 3 plus 2x. Now you can integrate this very easily. Using the linearity, you can integrate each term alone. So for this one, you will leave the 2, and then you will integrate x power 5 to get x power 6 over 6. Same here, you will leave the minus 4, and you'll integrate x power 3, you'll get x power 4 over 4. And same here, you leave the 2 and you'll integrate x to get x squared over 2. Now just simplify, you'll get this form. So we were able to solve this integral by expanding. Now what if you have this integral? 2x into x squared minus 1 to the power 7. So it's the same, but the power differs. What can you do about it? Would you expand? Would you write x squared minus 1 multiplied by itself 7 times in order to expand it? I know that it's doable if you're bored and have nothing better to do. But what if it's to the power 100? Or even 1 million? So we need to find another way. So we need to make it simpler. So here comes the importance of the change of variable method. So we want to rewrite this integral using another variable that makes it simpler. So now I'll explain what I mean. So this is the integral that we were solving. I want to choose another variable. It's often denoted by u, but you can denote it by any letter you want. I want to choose u to be one of these functions here. So it can be 2x, it can be x squared minus 1, it can be x squared minus 1 all to the power 7. Now the thing is how to choose the convenient u. You need to choose u such that you'll be able to rewrite this integral all in terms of u. So you need to choose u such that its derivative is also found in this integral and such that u and its derivative cover all the integral. So you can rewrite all the integral in terms of u and the derivative of u. So for example, if you chose u to be 2x, then the derivative of u would be 2. So you won't cover all the integral. So you won't be able to write x squared minus 1 to the power 7 in terms of u or u prime. Now what if you chose u to be x squared minus 1? The derivative would be 2x, which is found in the integral, and now it's all covered since 2x is the derivative of u and x squared minus 1 can be written as u. So this will be u power 7, and you covered all the integral. What I mean by covered all the integral, I mean that you were able to rewrite it in terms of u. So let's start. Let's choose u to be x squared minus 1 as we said. So u prime would be 2x. Right? The derivative of x squared minus 1 is 2x. But instead of writing u prime is equal to 2x, we will be using this notation. So for u prime, instead of u prime, we will write du. So this means the derivative of u, but on the other side, we will write dx next to the derivative, which means that we we differentiate with respect to x. Now let's write the integral in terms of u. So instead of x squared minus 1, we will write u. So instead of all of this, we will have u to the power 7. Now let's look at du. Du is 2x dx. So instead of 2x dx, so what's left, we will write du only. So we will get u to the power 7 du. So see how much it becomes simple. Look back at the original integral and now look at the new integral which is written in terms of u. Now in order to integrate this function, it's very easy. You add 1 to the power and you divide by the new power. So you get u to the power 8 over 8 plus c. But look back at the original integral. It was in terms of x. So you need an answer in terms of x and not in terms of u. So you just simply replace u by x squared minus 1. So by your substitution. So you will get, instead of u, I'll write x squared minus 1. So it will be x squared minus 1 power 8 over 8 plus c. Be careful not to forget the last step because many students do so. So first you write the integrals in terms of u, you integrate it, and then you write it back in terms of x. Now, what were the other options for u? So we can choose 2x, for example, or also we can choose x squared minus 1 all to the power 7 and not only x squared minus 1. Let's see why they don't work. So if you chose u to be 2x, then du would be 2. The derivative of u would be 2 dx. So you can't write x squared minus 1 to the power 7 in terms of u or du. So it doesn't work. What if we chose u to be x squared minus 1 all to the power 7? Then the derivative of u, denoted by du, would be 7 into x squared minus 1 to the power 6 times 2x, which is the derivative of x squared minus 1. You should be able to do this derivative. Anyway, we will write, so u is x squared minus 1 to the power 7, so this would be u. Now for du, it's all of this. So you don't have x squared minus 1 to the power 6, so it doesn't work. Before we do other examples, I'll give you a small hint or tip on how to choose u. It doesn't work in all cases, but I can say that it works in most of the cases that you encounter. So u is usually what's under the power, like in this case x squared minus 1, under the radical or in the denominator. But basically, you should choose u such that du is also found in the integral and such that u and du covers all the integral, as I said. So now, what if we don't have this two? What differs in the way of solving? Does u change? Should we choose another variable in this case? Because you say that u is x squared minus 1, but du is 2x, and we only have x. So let's see. So integrate x into x squared minus 1 to the power 7, so we don't have 2 now. So basically, as I said, you should choose u such that du is also found and they cover all the integral, but du can differ by a constant. So it can differ by a multiplication of a constant. So what I mean is that if we chose again u to be x squared minus 1, we will get that du is 2x dx and not x dx. But that's fine if it differs by a constant because you can add 2 here and divide by 2 again. So as if you didn't change anything, but now you get the 2. So as I said, I'll multiply by 2 and divide by 2. So I'll divide by 2 outside the integral because as you know we can get the constants outside the integral using linearity, but it's fine if you keep it inside. So now I have 2x as I want. So now I can rewrite it in terms of u as I did before. So I have half outside, and instead of this, I'll put u, and you have to the power 7. And instead of 2x dx, it'll be du. So the only difference is that you got half now. The integral here is very easy, as we did before. And then don't forget to replace u by x squared minus 1 again. Now this is another example. So suppose that you have this integral. For sure, you will use change of variable because it's not very simple or not simple at all. So how do we choose u? If you chose u to be 2x plus 1, then du would be 2. Okay, which is also found, but what would you do with x squared plus x minus 5? You can't write it in terms of u or du, so this doesn't work. So use the hint that I said. I said that it's usually under the power, under the radical, in the denominator. So it's probably x squared plus x minus 5. So start by trying these. So if u is x squared plus x minus 5, then du is 2x plus 1. So let's see if u and du cover all the integral. So instead of this, we will be writing u to the power 11. And instead of 2x plus 1 dx, we will be writing du. And we're only left by 2, which is a constant, so it doesn't matter. We can just take 2 outside the integral. So it works. So take 2 outside the integral because you don't need it. Now, instead of x squared plus x minus 5, we write u. So we get u to the power 11. And instead of 2x plus 1 dx, we have du. So we got this form, which is very, very simple. Now we can integrate it by adding 1 to the power and dividing by the new power. Now don't forget to replace u by its substitution, which is x squared plus x minus 5. And 2 and 12 simplifies to get 6. Now suppose that you have this integral, which is the integral of 5x squared over x power 3 minus 2 all squared. Again, this is not simple, so we need change of variable. So how can we choose u? As I said, we will start with what's under the power or in the radical. And usually when you have a fraction, it's usually what's in the denominator. So we will try x cubed minus 2. So if u is x cubed minus 2, then du would be 3x squared. Let's see if it works. So here, instead of this, we will be having u squared, and we're left with 5x squared dx. We look at du, it's a 3x squared dx. It's the same, but it differs by a constant. And as I said, if it differs by a multiplication of constant, then it'll work. So we need 3x squared and not 5x squared. Since we don't need 5, we just take it outside the integral. And now we need 3. So as we did in the second example, you multiply and divide by 3 to get 3 here. So we took 5 outside the integral and you multiplied by 3 and divided by 3 because in order not to change anything. So you'll get this form. Now you have du, which is 3x squared dx, and this is u. So you just substitute. So you'll get 5 over 3. Instead of 3x squared dx, you'll have du. And in the denominator, you'll have u squared. Now, how do you integrate this? We did a lot of them in the first video. So you just take it up to become u to the power minus 2. Now you can integrate it. You add 1 to the power and you divide by the new power. So minus 2 plus 1, you'll get minus 1. And then I'll just take the minus outside. So I'll put it before the fractions just to get a better form. And in order to get a positive power here, I'll just take it back to the denominator. So it becomes u to the power 1. So u. Now, again, don't forget to replace u by its substitution, which is x cubed minus 2. And you're done. Now I advise you to stop the video and redo the first 3 examples by your own and check your answer, and then solve this integral alone. So the integral of x power 5 radical x to the power 6 plus 3, we need to choose a convenient u such that its du is also found in the integral and such that u and du cover all the integral. So I'll start by choosing by trying u to be x to the power 6 plus 3, since as I said it's under the radical. Then du would be 6x to the power 5. Let's see if it's found. So instead of this, I'll write radical u. Now we're left with x power 5 dx, which is pretty similar to du, which is 6x power 5 dx, but it only differs by a constant. And as I said, if it only differs by a constant, then it'll work. So as we did in the previous examples, if there is a constant in the integral that you don't need, just take it outside the integral And if there's a constant that you need, you multiply and divide by this constant. So in this case, we need 6 next to x power 5. So we multiply by 6 and we divide by 6. So we'll get this form. So we multiplied by 6 and we divided by 6 outside the integral because we don't need it. Now we can rewrite this in terms of u and du. So instead of x power 6 plus 3, we will have u. So we will get radical u. And instead of 6x power 5 dx, we will have du. So it will be very simple. Now, in order to integrate this, we did a lot of it before. So we will rewrite radical u as u power half. So now you just add 1 to the power, so it becomes 3 over 2, and you divide by the new power, which is 3 over 2. I'll go over these steps very quickly because we also did like them in the first and second video. So this becomes 3 over 2 becomes 2 over 3 in the numerator. And now in order to simplify u power 3 over 2, or in order to get it back to the radical form, this stands for the index of the radical, and this stands for the power. So we will get radical u power 3, and then this will simplify into u radical u, because it can be written as u squared, and u squared gets out as u. Now we replace u by x power 6 plus 3, so by our substitution to get this form, and always plus c. Now we have this example. Also try to do it by your own. It involves trigonometric functions. So we have 3x sine x squared. So let's think, what can our u be? If it's 3x, then the derivative of 3x is 3, but you can't write sine x squared in terms of u or du, so it doesn't work. Try to choose another u. If you choose u to be sine x squared, then the derivative of sine u is, if you remember from the chapter of derivative, it's u prime cosine u. So it will be 2x cosine x squared, which is not found in the integral. So it also doesn't work. So what do you have now? The only option now is x squared. Let's try x squared. If u is x squared, then du is 2x. Let's see if it works. So here we will have u. So instead of sine x squared, we will have sine u. And then we're left with 3x dx. Again, we look at du. It's 2x dx, which is pretty similar, but it only differs by a constant. Then this means it'll work. Now we need to change the form of this integral because the substitution differs by a constant. We need 2x and not 3x. So as I said before, the number that you don't need, take it outside the integral. So we will take 3 outside the integral. And the number that you need, which is 2, you multiply and divide by the number. So we multiply and divide by 2. So as I said, we take 3 outside the integral, and then you multiply and divide by 2 to get 2x. Now you replace 2x dx by du, and sine x squared is sine u, because u is x squared. So now you have the integral of sine u, which is very simple. So you'll get 3 over 2 into minus cosine u, which is the integral of sine u, plus c. Now just take the minus outside, so it'll be minus 3 over 2 cosine u plus c. Again, don't forget to replace u by its substitution, which is x squared. So you get minus 3 over 2 cosine x squared plus c. Now this is the last example. Try to do it by your own. We have sine x cosine power 3 x dx. So what kind of substitutions we can have? As I said in the hint that I gave at the beginning of the video, it's usually what's under the power. So here, what's under the power? It's cosine x, because here we have cosine x all cubed. So let's try u equal cosine x. Then du would be minus sine x dx. Let's try to rewrite this to see if it works. We will have here, instead of cosine x, we will have u. So we will get u power 3 here. And let's look at du. We have minus sine x dx. And here we're left with sine x dx, which is pretty the same, but it differs by a constant, which is minus 1. So we can put a minus here, but we should add on also minus outside the integral. So now minus and minus cancels out. So we got a minus inside as we want. Now we start with replacing. So instead of cosine x, we have u. So instead of cosine cubed x, we will have u power 3. And instead of minus sine x dx, we will have du. So we will get minus integral of u cubed du. The integral here is very simple. And again, we replace u by its original substitution, which is cosine x. And don't forget plus c. Try to use other substitutions and you'll figure out that they won't work. And you're done with this part, and we're done with this chapter for grade 11. Now for grade 12, I'll post videos for you, and I'll also post a 1-minute video after this video as an assessment for you to check your understanding for this material. So I'll be posting some exercises with their solution as a quiz if you want. Thanks for watching.